Oh my God, that's an interesting way of looking at what we're doing. Like, we can't actually, we're not doing the work ourselves, just piling it onto the DevOps people to fix all of our coding problems.
So it's I call it as a journey from DevOps to GreenOps, then FinOps and so on. Yeah. So you integrate all of these and then get a highly sustainable software or system.
As long as it's not my ops. As long as it's somebody else's ops, it's not my problem. I'm joking. Hello and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Asim Hussain. Welcome to The Week in Green Software, or TWiGS, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Asim Hussain. Today, we'll be discussing the latest development from a bunch of people, but on the call, we've got Navveen from Accenture, and we're going to talk about some of the work that they've been doing calculating carbon emissions using what's called the SCI Specification, which we've been developing the Green Software Foundation. And we'll also be sharing some valuable resources and some exciting events to do with the world of green software. Before we begin, let me introduce our guest for the episode of TWiGS. With us today, we have Navveen.
Hi, everyone. I'm Navveen Balani. I'm a Chief Technologist with the Technology Sustainability Innovation Group at Accenture. Very excited to be here. I look at innovation and creating assets at the intersection of technology and sustainability. I'm also a Google Cloud Certified Fellow and a published author with several technology books.
Wonderful. And I did discover just how many books Navveen has been writing. You go to his Amazon profile. There's quite a few there. I know how hard it is to write one book, Navveen, so I'm quite impressed. Over to you, Srini.
Hi, I'm Srini. I'm with Microsoft and I'm working for the sustainability division of Microsoft. Sustainable software is something that it was just a spark about 3 years back in January when the goals around carbon emissions were announced. And I immediately wanted to do something within the consulting space for which I was part of at Microsoft. But I'm happy to be here. And then Green Software started and I've been with them since, I think, the beginning. And as far as my interest with green software is going, I like to write a lot of blog articles because they're small and probably can finish it within a couple of weeks. A little lazy that way. But yeah, it's been exciting working with GSF, the different groups. And I just look forward to learning a lot from this initiative.
Wonderful. And it's great to have you both here. And you've both been involved in green software since before the foundation were born. You've both been involved since day one of the foundation. So yeah, really appreciate it. So let's go with the news. Let's start off with the first piece of news. So this is a piece on our website, which is called How Accenture Implemented the SCI Specification Score to Track Software Emissions. We were going to cover this last week, but we figured it made more sense to wait till this week so we could be joined by Navveen. Because Navveen, you work at Accenture and you're one of the authors of this post. So yeah, why don't you tell us people a little bit about what the article's about? And I'd love to know, what were some of the challenges you faced while trying to calculate the SCI specification? And just very quickly, just explain to everybody, the SCI is something called the Software Carbon Intensity Specification. And it's a specification being developed by the Green Software Foundation to measure carbon emissions of software. So yeah, over to you, Navveen.
Thank you, Asim. SCI provided us with a practical methodology to baseline carbon emissions of our software application, included embodied emissions and reducing the same. And when we started realizing the SCI specification, we found out getting accurate data for energy and embodied emissions was quite challenging. And as we were deploying the application on cloud, many of these details were abstracted by the cloud vendors. So we had to change our focus from getting accurate data to probably approximations and work towards getting a baseline for our SCI score. And once we had the SCI score, we basically have a value to track. And as long as you use the same approximation, you could easily identify what caused the reduction in TI code. For instance, did you change the code to be more energy efficient? Or you did hardware optimizations, and based on hardware optimizations, the energy estimation got reduced. So with SCI and using this, SCI as a score, we were able to in our carbon emissions. And once we had the score, we went about with various reduction techniques.
So you calculated the SCI score using a type of like a reference architecture. Could you describe the type of application that you were trying to calculate a score for?
Yeah, so our reference architecture was basically a 3-tier application which was deployed on the cloud. We had user interfaces created using web application. At the back end, we have developed all the application code was available as a set of containers, which was deployed on a container management. We had an API gateway, which all communications happened through the API gateway. And at the back end, we had a few databases, NoSQL and SQL databases, which stored the data for the application, as well as analytics information. And then we had other cross-cutting concerns like security, logging, right, which is provided by the cloud vendors.
So it's basically like this is about 95% of all applications in the world is this, basically, right? Apart from a database, an API, and some compute using one mechanism or another, the virtualized machines or something else. And you mentioned earlier, because I think the thing you mentioned at the start is the thing that comes up all the time, which is the data problem. It's a data problem. I think it's a problem that we three have discussed for quite a while now. So what were the solutions? Like, how did you solve the data problem to be good enough for you? As in, like, how did you solve getting good enough data for you?
Yeah, getting data was a challenge because most of the data, right, is currently not available, or I would say readily available. So we have to look at certain approximations. For instance, the first was around energy calculation. And there are various approaches to calculate energy curves. Some are based on coefficient values, like how many watt hours it would take to run a virtual machine. Some are based on statistical methods, and some provide methodology through a set of APIs. And most of the energy calculation strategies are based on certain approximation. So there is no single source of truth. And the intent here is to basically use the same methodology for any future calculations. So you could actually have a baseline and then you use the same approach again and again to find out the SCI score.
So when you say an energy curve, you're talking about trying to calculate how much energy is actually consumed by a CPU. Because it's a curve, right? It's not linear.
That's right.
It's a curve. Yeah. And so what did you land on in the end? So which solution did you land on in the end? You mentioned a couple of solutions there.
We went ahead with a combination of a statistical based method and APIs which were provided through various third-party sources. And we found out that we have to pick up one of the values. So we went ahead with a statistical based method, which provided, in our instance, a better accuracy, I would say. So our concern was to find out with what accurate method will we end up using, right? So statistical base gave us a good, I would say, benchmark. But even if you have picked up the API method also, it was not more about accuracy, but I think it's more about getting a value, right? So that we could unblock ourselves to arrive at an energy curve.
And so that's basically I consider myself the simplification. I'm the 5-year-old on the call and you have to explain it. I'm asking the 5-year-old questions. So you're basically talking about being able to provide some model with some inputs, be it, I'm guessing, CPU utilization, maybe RAM usage, maybe it depends how much telemetry you can gather. If you can gather as much telemetry as possible and passing that into a model, which then just pumps out for you, given all these inputs, we guesstimate your energy consumption is that amount, because you actually don't know. Like I can tell you from like Intel's perspective, I'm working at Intel now, so I can tell you from Intel's perspective, like we have certain tools, like for instance, there's Intel's RAPL, but Intel's RAPL only really gives you data at the socket level. The mechanical mechanism of being able to calculate electricity, we can only give it you at the socket level just because that's the pipe coming in. And there's lots of to get that to process level, you have to do lots of modeling to try and figure out how much of that incoming value do we partition off to all the processes running on a machine. So at some level, you always have to use statistical modeling, even if you've got like a direct measuring capability, I'd say, yeah.
So yeah, as you pointed out, right? So it was, as long as you can get telemetry data, whether it's CPU, memory usage, storage utilization, network input and output bytes, right? You can convert it into some energy curves using some statistical models and get a value which is your energy curve.
So let me ask you another question. So Srini, you and Navveen are there's a rare set of people in this world who've actually tried to calculate the emissions of software. I think I used to say there's only 2 or 3 people who've ever attempted it. And now it's probably more like 10, 12, but there's a small, limited skill set. So, and I'll start with you, Navveen, but I'll ask Srini as well. So what are your key takeaways from implementing something like the SCI specification?
Yeah, so that's a great question. So I would say we had 3 key takeaways from this case study. One was around energy calculation. And as I mentioned, there were various approaches for calculating energy curves. And there was no single source of truth. And the intent here was to use some method for future calculations to compare against the baseline. And we documented the various approaches as part of the SCI guide project, which I worked with Srini. And this can be a starting point for all software practitioners to calculate energy of the software system, whether it's using statistical methods, coefficient, or API-based technique. The second takeaway was around embodied emissions. So the type of underlying hardware for running virtual machines and its embodied emissions are currently abstracted by the cloud vendors. And we had to rely on certain approximations based on VM type to calculate the embodied emissions. And we relied on sources from the cloud carbon footprint, which had an Excel which talked about for a given virtual VM type, what is the scope 3 emissions. And there's a similar study from Vista also, which talks about the scope 3 emissions for a given hardware type. And the third was around the cloud managed services. So there were certain managed services and shared services like the API gateway, load balancer, but the type of hardware is not listed by the cloud vendor. In such scenarios, we had to rely on certain approximation like we did with API gateway. We just assumed 5% of our total carbon emissions goes to API gateway. And for serverless components, we relied on using a timeshare approximation and the utilization to come up with a carbon emission score.
So for serverless, you just assumed it was like on normal workload, but just you time shared it because underneath, it's a normal workload. It's a normal server that's been using it underneath. There is a server behind serverless. Right. Yeah.
So we wanted to attribute some value to it because we thought, okay, maybe a 5% based on our overall load might make sense. So at least give some emission value to the API gateway.
Yeah, good takeaway. Srini, as somebody else who's been calculating SCI scores for a while, do you have any other takeaways from your experience implementing SCI scores that you think might be useful for other people to know?
Definitely. Thanks for the question. I think I completely echo what Navveen said about learning how to do embodied emission calculations as well as for serverless. Other couple of things that comes to my mind. The first takeaway I would say is from the case study that I picked up was very similar to what Navveen was talking about. Mine was a managed services set of managed set of services combining to form a website. It's as simple as that. You had a web application, you had a middle. I didn't even have an API. All that I had was a direct database. But to make things simple for me, I chose managed services from a deployment standpoint. But from a calculation standpoint, it's the most hardest thing because a lot of abstraction is happening under the hood in terms of, like Navveen was said, the database server, the front-end server. And also, if you talk about real production application, you have replication, you have active configurations, active passive configurations. So the first takeaway that for me was from an infrastructure standpoint, the complexities around the deployment. Do we take into account the development machines that help build that infrastructure in the place? What should be included? What should be excluded? So for me, the first and foremost thing is to define or be very clear around your software boundary. And that's where you need to make it iterative. Try not to boil the ocean in the first place. Say, I've included everything. No, that's not how it works, right? You need to iteratively keep adding, and your calculation also ends up becoming iterative. Second takeaway, I would say, is the networking piece, which was, I think we have talked about it enough in many of our group calls. It may sound the easiest to measure, but it's the most difficult to calculate. I can just go in and say, this is my data in, this is my data out in bytes. Hey, give me the number. There's no reference number at all. There's no reference multiplication factor that you can use. So I believe there are lots of studies going on, and this is an area where We could do a lot. We could invest in a lot of academic research to figure out what would be the best way to do this. And third, I think for me, a revelation was I needed to brush up on my high school physics. I needed to understand what's energy, what's power, what's joules. It's very important. It's just not software development anymore. If you talk about sustainable software, you need to know your basics. And so you should study.
I can tell you as somebody who's moved from like software development at Microsoft to Intel, I ask questions which I think are just, I'm expecting an answer, oh, code it this way. Half my answers involve the word voltage. It's somewhere in the answer. And I'm like, whew. It's almost like a lost art. And I wonder if the secret to all of our world is this. There's like a lost art to programming. Back in the day, like what you described, and I talked to a lot of people at Intel who write software at a very low level, and the understanding of what you're saying is inherent. It's natural. We've become so abstracted away. And the abstractions are useful because make for faster development. But there is a nature of understanding how the distance between programmer and silicon has become quite distant. Whereas if that reduced, that'll be in something I think that interestingly might help us in our space. I've been thinking about this. I don't know if I've spoken to both of you about this yet, but this idea that I've had around, like you mentioned software boundary, Srini, and it's something we've spoken about a lot. I know, Navveen, you've been driving a project for a while now, the Scientology, which I think we should change that name, Navveen. It's just a suggestion because it's Scientology. But anyway, you've been driving a project around like when someone says my application, what do they mean? What do you include in an application and what do you not include in an application? Because one of the things that I've seen historically when people publish carbon footprints for applications is they conveniently cut out bits that are either just inconvenient to calculate, but they are part of your application boundary. Like I've been thinking a lot about monitoring, like the monitoring of an application. Like when you have these larger applications, you're monitoring all these different components of your software product. You're monitoring the database, you're monitoring the front end, you're monitoring this, you're monitoring that. And I've been having this idea that what if you defined your software boundaries, everything that if you care enough about some software component to monitor it, is that philosophically part of your software application? Does that make sense what I'm saying here right now?
Definitely. And I think if you want to make it systemic, if you want to make your calculation systemic and repeatable, that's how we do, right? When we want to calculate the number of users who are actually using their application, we fall back to telemetry. We use words like user journey and scenarios, etc., etc. But then here, if you really want to understand what are your operational emissions, you need that telemetry. You need that telemetry across all the software components in your system. So yeah, definitely, it's a must-have.
I also think maybe if there is a simple way to calculate operation emissions and carbons directly from the data which is already being available or gathered, the whole generation of SCI score might be very simplified. Maybe do whatever data you have, if you are maybe proxy data, cost data, and some efficient way of converting that to a score. Because one of the challenges I would say is going through the SCI require a fixed set of steps, right? Defining your boundary, calculations, coming up with the conversions. And so it has a sequence of steps. It takes time. But with any available proxy data, if you are able to quickly generate a SCI score, at least some benchmark, I think that would be an ideal scenario. And maybe it's integrated as part of your DevOps in future. So you don't need to do much, right? Just build, get a score, next release you build, get a score. Maybe you're not there yet, but hopefully that's the intent and direction.
Yeah, it's come up a couple of times on the podcast about the green ops, dev sus ops, that aspect of it. And actually monitoring is part of that. That's what you think of when you think of DevOps. And is it? I think it is. There's monitoring. I hope it is. Someone should be monitoring my applications. It's not me. I hope it's the DevOps people. Maybe the DevOps people think it's me. But
now we are giving more additional responsibility to DevOps, I would say.
Yeah. Yeah, that's just oh my God, that's an interesting way of looking at what we're doing. Like we can't actually we're not doing the work ourselves, just piling it onto the DevOps people to fix all of our coding problems.
So I call it as a journey from DevOps to green ops, so then FinOps and so on. Yeah. So you integrate all of these and then get a highly sustainable software or a system.
As long as it's not MyOps. As long as it's somebody else's ops, it's not my problem. But I'm joking. So maybe let's bring it back down to an interesting, I think both of you also work on, I think I teased in a previous podcast episode, this idea of something called the CarbonQL project, which Srini, you're leading, you're both heavily involved in. Let's flip over into that and talk about this brand new project that we're launching in the foundation called CarbonQL. Do you want to give a quick overview?
Definitely. Thanks, Asim. Again, this has been something that I'm really excited that it's going to change the way we look at carbon value, or how are we systemically capturing, monitoring data. The intent of the project is to be able to provide a value, a carbon emissions value, which you can use. It's more for action, for you to continuously iterate and figure out where are you at a particular milestone after you have taken some of the measures provided as part of the SCI specs, which is around making it more carbon aware, making it more efficient or energy efficient, or all of it. So you need a way to tell whether you have progressively made it past your different milestones, whether you're continuously reducing or you're stagnant or you're increasing. Because it's always possible that you need to pull all these parameters to make sure, because we are not building applications just to make it sustainable, right? We are building applications to make money for your business.
Add value to the world. Let's put it that way.
Exactly. And so you need a way to easily calculate across your different hosting infrastructure, whether you do it on the cloud or on-prem, you host your app on your laptop. The project aims to tap into the different data sets available and abstract away the calculation algorithm and just provide you a value, most intelligent value. That's what we would say. And we've kickstarted it, and I think it's going good. We should probably have something really cool coming out of this. Navveen, do you want to add anything?
So maybe I think CarbonQL can be a chat GPT of sustainable tech. You ask questions. What is the emission for laptops? What is the emission for mobile phone? What is the emission for your CPU? What is the emission for my software boundary? You give a spec, right? So it can be as easy as you just give a spec or a software boundary or the artifacts from SCI ontology. If you define something and just say, please provide me emission. So it can make life easier for people who want to calculate carbon emissions and maybe provide a simplified way of getting carbon emissions, be it for developers, DevOps. If we're able to provide that vision and implementation, I think the calculation journey would be quite simplified and more adaptable, right, to all the development community.
So I think we've mentioned ChatGPT every episode for the last 10 episodes now. So it's come up again. Yeah, just for the audience, it is not a flavor of ChatGPT. You are not going to be typing in, what is the carbon emissions of my 3-tier thing? I think what you're alluding to is there's quite a few different methodologies and data sets and models and statistical models you can use. And are you on a laptop? Then maybe you want to use this model. Are you calculating from mobile phone? Maybe use this model. Or a server, use this model, or this API or this data set. And I think what I've always found is that the set of people, like you two are a very rare set of people who've actually sat down and calculated this stuff manually. The knowledge that's in your head is rare. Actual real experience. People can read like roughly, theoretically how to calculate and sum it all together, but you've actually got like that real knowledge. And what I see is a CarbonQL is going to try and codify that so that anybody else does not need to be an expert in this space. They can just say, I'm using the Greenhouse Gas Protocol methodology. I'm running on these types of machines. This is the telemetry I've managed to gather, but I don't really have all of it. And then you'll just figure out the rest. And like use all of your expertise and all of your best judgment to combine all the data sets into one, which I think is, it's been the number one problem I've heard from everybody about the SCI since day one was data. It's really hard. There's lots of data sets out there. We don't even know if they can merge. I get this number from one data set. I get a number from another data set. Can I add them together? Is that possible? We don't, so the set of people who know that is low. You're two of the sets of people who know that.
I think the data, once we have CarbonQL implemented, right, I think through the data, we'll get various insights across all data sources. Maybe that might be a good way to look at the various data trends, right, across all these APIs and see, right, whether we want to use average value or which works for a given scenario.
Yeah, I'm really excited. I'm really, really excited for this project. I think this is one of the projects we've it's been on the tip of our tongues for a while now. And it's just really exciting to get it. And there's been a lot of interest from various organizations in the foundation from getting involved. So there's a lot of interest in this. So really excited to see what you both and the rest of the team deliver on this front. And we'll get you on the podcast again as things get a bit more mature to talk about kind of where the progress is. Let me move on now to a few of the other bits of news. One other bit of news that's happened recently is a PowerShell module for WattTime emissions data. So WattTime are one of the organizations that provides carbon intensity for electricity. They remember the foundation. So Henry Richardson and the team at WattTime have released a PowerShell module that retrieves near real-time emissions data from WattTime for a supplied Azure region during resource deployment. This is a really lightweight solution. It utilizes the limited functionality available with one of the WattTime's free accounts because it is a paid, they do need to earn money. And it's not really like a real solution for reducing carbon deployments of software. I imagine to get that data, you probably should pay for the full licensed versions of the data and get the more accurate data. But it does provide some nice real-time values to simulate the behavior of deployments and software based on emissions without the cost of a paid account. So what will they need? They'll need an account on WattTime. You'll need the AZ Resources PowerShell module for Azure installed. You need to connect it all to your Azure account, which is a really great free resource, which we're going to link in the show notes. Are any of you PowerShell users? Are either of you PowerShell users? Because I've got to admit, I'm not.
I have used it.
You have used it. Srini's like, I work at Microsoft. I should know. I should be a PowerShell power user. But you're like how I used to be at Microsoft, which is I don't really use SharePoint. But yeah. PowerShell. Yes, PowerShell it's like a command line tool, from my understanding, for Windows, isn't it? Yeah. So it's really exciting because I know it's used in a lot of DevOps scenarios. Really simple idea. We think so complicated about the world that we do. This is a really simple idea. Just bringing a lot of this functionality into the command line interface all by itself is, I think, quite valuable.
No, I just remember we had a similar innovation, right, in the hackathon that we did. Something around Shell trying to get carbon intensity.
Circa. That was it. It was called Circa. Yeah, in the hackathon we had last year, that's a good memory. We had I remember now, there was one of the submissions was Circa. It was one of my favorites, and it was a command line where you typed Circa, then you typed the command that you wanted to execute, and it would literally just do a sleep. Such a simple idea, just a sleep on the command line until the electricity becomes better, and then it lets the command run. So all these simple ideas, really, really good. So let's move to the next one. So Sustainable Design Toolkit for UX Designers. This is from Vitaly Friedman. I've met him. I've spoken at his Smashing Mag conference. I've met him at quite a few conferences. So Vitaly, if I pronounced your name wrong, I'm really sorry. So he's released a really cool list of sustainable design toolkits for UX designers, all with practical guidelines, frameworks and tools to focus on what matters and removes what doesn't. The list is really comprehensive and includes a UX checklist for sustainability. It looks really useful. Again, the link's down in the show notes. I took a quick look at it earlier on today. He posted it. There's a big post on LinkedIn, and there's a lot of great stuff. I get asked about this. I just got asked about it last week. I spoke at a conference, and people are asking for like a UX framework because a lot of what we're talking about starts at the UX level. Do you need to build some of this functionality? I remember there was one, again, like coming back to the CarbonQL hackathon last year, there was one proposal, which I thought was really interesting, which is like CarbonQL components you can put into websites. So like a literal CarbonQL, I think it was carbon video or something. You can type a HTML tag called carbon video, and it would play the video if the electricity was clean. And if it wasn't clean, I think it would just play the audio component of the video, save on energy or something like that. So I think a lot of this stuff, it all starts really at that stage. Before you even speak to a developer, it's probably the best time to do a lot of your sustainability thinking. Did you guys have a chance to look at this? Don't worry about it if you don't. UX is for the other folks.
I think given how the UX will evolve, right? Particularly new interfaces, maybe in metaverse, right? I don't know. We will have a lot of thinking to do to decarbonize the entire UX story. Not now, maybe when you see a lot of emissions where everything is virtual, I don't know what kind of carbon emissions we would have, right? Maybe 5 years, 10 years down the line.
Yeah, very interesting point. Or maybe the only interface we'll have 5 years down the line is a version of GPT. that just work GPT, or your laptop just opens up and it's chat GPT like command line at the bottom and that's it. There's nothing else left for us to do my work for the day. I joke about this. I had to hunt around for it, but I actually found 4 years ago, I was giving a talk. I think I tricked an audience into thinking I'd built an AI that could make a website from a textual description. I tricked the audience. And then just last week, it happened. And now the chat GPT-4 can see a picture of a website and code it for you. So I wonder how long we've got left. Probably not as long as we think. But while we're here, let's make sure we go out with a bang. Last thing, I'm going to talk very quickly about really excited, the meetup program. So the Green Software Foundation has a meetup program where we support meetup groups. If you want to launch a meetup group around green software in your region, or actually we've got like 20 regions where we already have members of groups, but we're actually missing organizers and leaders. If you're interested in launching a meetup group or taking over or co-organizing a meetup group, or even speaking at meetup group, or even being involved in any which way in a meetup group at all, go to meetup.greensoftware.org. I'm very excited because this week, actually, GSF, the London meetup, which is the first one that we're launching now, is having an event on Thursday, March 23rd. At 6 p.m. GMT. It's at the MasterCard offices in Angel Lane in London. There's more links in the show notes. Chris Adams is going to be there. So he's visiting from Germany. Leah Matthew and Sarah Sue from Goldman's is going to be there. Daniel Vaughan is going to be there from MasterCard. And big thanks to MasterCard for helping us host this event and offering the venue. So if you're in London and you're listening to this podcast, pop over to the meetup Thursday at 6 p.m. And if you're interested in launching a meetup, please reach out to us and we'd love to get your help and we'd love to help support you launching a meetup. So that's it for our news and events roundup. As part of the new format of TWiGS, we have a short closing question that we'd like to ask our guests, and it's going to be different every single week. So whilst I go and figure out my answer to this question is going to be, I'm going to ask Srini, what is a go-to green website that you have bookmarked in your browser?
So we are part of a sustainability action group within Microsoft. And a couple of months back during one of the community calls, there was a website which I found interesting on green jobs.
Oh.
Yeah. And I don't think it's a career website or a job search site, but I found it interesting that it collated all types of green jobs. It could be an electrical engineer. It could be as simple as a sustainability policymaker. So I think I have it in my bookmark. I keep looking at it and trying to understand what types of careers are there in the sustainability space.
Wonderful. Great. Send it over our way. We'll put it in the show notes. Yeah. Navveen, what go-to green website have you bookmarked in your browser?
Interesting question. I would say, I think the simplest answer would be go to google.com. I think from a technology perspective also, and from a sustainability perspective also, they have a very simple interface where you can get whatever information you want, right? So I really love the way they have, for the last 10 years, made the search more, minimalistic, I would say. For the 2 decades, I would say, I haven't seen it change much. And maybe through that, I'll explore more websites. But yeah, that is what I think it comes to my mind. It's probably billions of people might be using.
Just remembering, like back in the days when like search engines were like appearing, like there were just big messes on the screen, but Google's was just like this empty page and then this thing in the middle, and it was like a breath of fresh air rather than all these other sites you're going to. So for me, I've got to be honest with you, like my head is fully in the foundation and kind of I was just literally checking my history, my bookmarks right now, and like we're currently like building out a wiki. So like pretty much every other bookmark right now on my website is a wiki page where we're trying to flesh out like every single aspect of, I joke that I manage kind of the operating system for the foundation, and we're like building out what the operating system is and how we work and how to get involved. Lots of information there. So that'll be coming up, not right now, but in a future episode, we'll be releasing the wiki. But that tends to be what I'm working on. The only other kind of, I think, website that I really love in this space is Branch Magazine, which is Chris Adams, who's the other host of this podcast, talks about, he built it originally. But it's a wonderful like magazine, which has like lots of articles about green technology. And the really cool thing about it's also carbon aware. So when the electricity is dirty, it doesn't show images. And when electricity is clean, so it kind of implements what it is. Oh, I have another one as well, actually. I just remembered another website that I admit I don't have it bookmarked because I just remembered it. But there's a website, and I just discovered it the other day. I think it's very cool. It's LOWWW carbon.com. And it's a showcase of low carbon websites, how they've done it and the case studies, how they implemented it, some examples. That's a pretty cool website I've got. So yeah, I didn't think I'd have any, but I've got a couple actually now, so it just goes to show. That's all for this episode of The Week in Green Software. All the resources for this episode and more about the Green Software Foundation are in the show description below, or you can visit greensoftware.foundation. That's greensoftware, one word, .foundation in your browser. If you enjoyed the show, please consider leaving a 5-star review on Spotify or Apple Podcasts or wherever you get your podcasts. Your feedback is incredibly valuable and helps us reach a wider audience. Thanks again for listening, and we'll see you on the next episode. Bye-bye.
Bye-bye. Thank you for listening.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show, and of course, we want more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. Thanks again, and see you in the next episode.